Alright, we're back. I don't think this video will be nearly as long as the other one, but, you know, whatevs. Again, copy the picture and try to fill out what you know. Something's not right here. This should be down more. This should be down more. Who did this? Someone messed up stuff. Anyway, so pause the video, give it a shot. Alright, we're back. Let me check. I think I may already have the answers for you. Boom. Get some. Okay? Remember, you know how to do these. You got to work around. Okay? And make sure you plug stuff in. I said arc AD is 40. BE is 32. And then from there, work your way around solving for it. Okay? Cool. We're going to talk about radii and chords today. How can I understand the relationship between a radii and chords? Oh, radii is plural for radius. Radius is singular. Yes, I know. I love the English grammar. So you should have a printout for this. Again, should. And find Chords Theorem number 1. Your box is going to look like this. I honestly think your letters may or may not be different from this, and you're essentially filling in the blanks over here. Should be some blanks. But chord theorems number 1, in the same circle or in congruent circles, two minor arcs are congruent if and only if the corresponding chords are congruent. So, if arc AB is congruent to arc CD, if and only if segment AB is congruent to segment CD. Okay, and I might even argue, put some tick marks here to show arcs are being congruent. Okay, so again, pause the video, jot this down. May need to make corrections on that worksheet I gave you, or you may just want to straight up copy this. Not 100% sure, but this is the main idea over here. Alright, here we go. Chords 2. Sorry, people texting me. It's late at night. I need to be in bed right now. Use congruent chords to find the arc measure. Guys, this should be real quick. In the diagram, A circle, D circle, BC is congruent to EF. EF arc is going to be 125. Find BC. Guys, this is congruent. That's congruent. That means this arc is going to be congruent to this arc. Okay, easy peasy, squeezy. I don't remember the expression. Also, these circles are congruent. Notice the radius is the same in both. Boop. Huh. Look at this. I try so hard to get these symbols correct, and this is what happens. Anyway, again, AB is congruent to CD. Blah, blah. Arc AB, blah, is 140, which means, oh, I love this song. Maybe you can't hear the song, but you know, whatevs. CD, again, chords are congruent, radiuses are congruent. This has got to be 140. Bien. Again, chords, exact same circle, so this arc should be the same as the other arc. Here's 25, arc again, Y should be 125. These fonts look goofy. I don't remember making them look like this. Now, deductive reasoning may argue that this opposite side is 55. Don't fall for that trick. Don't fall for that trick. If it is 55, I'm going to argue, what a quinky dink. Right now, I suggest you do it this way. 360 minus, let's see, 125, that 250 minus that 55. Again, if it's 55, I have to stress this. That is a coincidence. Okay? But I'm checking. Minus 250 minus 55 equals, well, guess what? Equals 55. I'm going to argue quinkydink. Because I'm telling you, if this were, if I were to move this point over a little bit, this point over a little bit, then obviously this number would shrink and this one would get bigger, okay? Don't assume jack crap. I did my math to make sure it was 55. Don't be making up rules in math. That's not bueno. You're not a math god. Ooh, Skittles. Chords number 2. Again, should have a little blank line fill in the sheet type thing in front of you. Letters may or may not be the same. We get it to look the same. But this one is saying that the diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So, in my case, if EG is the diameter and EG is perpendicular to DF, hence the little square there, and then HD is congruent to HF, making some marks, then arc, I'm just going to put GF, should be congruent to GD, because those arcs should be congruent to each other. Boom, get some. Again, pause the video, jot down what you need to. Alright, here we go. Bam. Number 3. See, number 3. If one chord is perpendicular bisector of another chord, then the first chord is the diameter. So, if, again, these letters should be matching your picture, if QS is perpendicular bisector TR, boom, boom, cut it in half, then blank is the diameter of the circle. SQ would be the diameter. Skadoosh. Something happened to my music. I'll be right back. Man, let me tell y'all, that stupid projector in the ceiling decided to turn itself off, which consequently turns my music off, which consequently makes me upset. Needless to say, SQ should be a diameter. Boom. Well, my bad. Yeah, pause it, jot it down, make sure it matches, blah, blah, blah. Turkey season. So, playing with the idea of theorems 2 and 3. If this is 25, this is perpendicular, that's a diameter, these two guys should be equal. So 25 equaling 5x, 5 by 5, no brainer, 5 should equal x. Same thing down here, perpendicular, bisecting, 5x, minus 7 should equal 3x, plus 5. Really quickly, killing 2 birds with 1 stone with this step. I'm about to burp. Oh, that felt good. Divide by 2, x equals 6. Skadoosh. Yep, I've seen better 6s too. There we go. Bam. Pretty stinking easy, I know. I am amazing. Go ahead and pause the video, try these out. Alright, we're back. Again, make them equal each other. Everything is there for the solving, for the picking, I don't know what you want to call it. Again, killing 2 birds with 1 stone by mixing 2 steps on 1 line. Because it's late, I want to go to bed. My eyes hurt. I had Chick-fil-A, so that's a plus. It's misty outside. It's 10:07. Just want to go home. I just want to go. Make these equal each other too. 8x minus 17 equals 5x. I'm not crying. Get back in there, tears. Add 17 to both sides since I moved the x's to the left-hand side. Again, killing 2 birds with 1 stone because I can. Chuck Norris's allows us, is it? It's 29. 12, 17, 29. I don't think that's divisible by 3 at all. Well, this is what I give an example of not too pretty. Let me just make sure. 17, add. Yeah, that ain't pretty. So I'm just going to go ahead and give a decimal for this one because I know it doesn't reduce. We're going to give it a 9.67. Oh, that's... My 6's are just not coming in today. 0.6. Oh my gosh! Y'all seeing this? And now the eraser's not working. I'm being hacked. I'm the only person at school and I'm being hacked right now. Oh my gosh, guys, are you seeing this? Golly, there, boom, done. Heavens to Betsy. Well, I tell you what, it's creepy being here at school late at night. I need to go home. I gotta go by the bank first. In fact, just talking to y'all just reminded me I gotta go by the bank. I better do that before I go home, because I will forget to go to the bank. Theorems 2 and 3, we got bit, set, dick. So, bit, sit, dick. And these are congruent, which makes these arcs congruent. That should be 16. Hey, those are congruent. That means these arcs are congruent. The whole thing's 140. Find CB. I'm telling you the whole thing's 140, so half of that should be 70 and 70. They want the whole thing BC. Oh my good grannies. The whole thing would be 120. Man, read directions, guys. Read the directions. Moving on. Go ahead and pause the video and think about this one. But don't you dare think longer than maybe 10 seconds. Yeah, I'm counting in my head right now. You're at 4, 3, 2, 1. That's right. TV's 121. This bad boy better be 121. Don't make these hard. We got to find the measures of CB, BE, and CE. Do you know what that means? Guys, this arc should equal this arc. Perpendicular. So I want to go 4x equals 80 minus x. We're going to add x to both sides. We get 5x equals 80. Divide by 5. Man, I love this song. I don't know if you can hear it, but I'm loving it. Ba-da-ba-ba-ba. I'm getting 16. 16? Sorry, I only got my little night lamp on. Yeah, it's 16. Can't even see my calculator. Now, man, these 6's are not happening today. Oh, there we go. Now, that's not the answer. This ain't anything about finding x. Nope. They want to find CB. So if we look over here, CB, we gotta go 4 times 16. And that's going to be, boom, 64. So that's CB. Put measure CB above it. Then they want BE. So that's 80 minus that 16 we just found. And we get, oh, check that out. Another 64. Is it a coincidence? I think not. We just discussed these properties but a second ago. So measure BE. I'm glad they are the same. Then they want CE. CE is the whole thing. 64 plus 64 should be 128, but you know, who knows? It's late at night. Yeah, it is. 128 degrees is the measure for CE. Remember, minor arc. Why is it minor? Because it's less than 180. What? Ooh, 4. I think this is the last one. Go ahead and pause the video when I get done so you can jot down these notes. I really feel like this is the one that has different letters. I don't know. I do know that in the same circle or in congruent circles, 2 chords are congruent if and only if they are equidistant from the center. We're talking about this guy and that guy. So AB is congruent to CD if and only if FA is congruent to EG. Line segments. Again, pause the video, jot this down, make correct. Oh, I still have Skittles in this bag? What? I really shouldn't be eating Skittles this late. I'm going to have nightmares. So, in the diagram, circle left, A bits to dip is 12. We're reading that guy and this guy should be equal. Make it happen. What's that expression? We're not going to do that. I'm going to subtract 7 next. Make it happen, Captain. Got negative 4x right here. Negative 8. Divide by negative 4. And get negative 2. Look, see, now there's something beeping in my room. I'm telling you, I'm scared. I'm going home after this. What do they even want? Find EF. EF 3, so we got to go 3 times 2. We get 6. Skadoosh. Alright, pause the video and try these out. Alright, we're back. 6x minus 12 equals 2x minus 4. 13x minus 24 should equal 5x minus 8. I'm not going to solve these. Pretty self-explanatory. Y'all could do this. Cool. Go ahead and pause the video and try this guy out while I eat some Skittles. Alright, I'm back, Jack. Find the length of a chord of a circle with the radius 8. 8. That is a distance of 5 from the center. What? Find the length of the chord of a circle. Alright, now this is a chord. And the radius of 8, there's 8. That is a distance of 5 from the center. Oh, right here. Distance of 5. We're talking about the chord is a distance of 5 from the center. The center's right there. Joy. Guys, this is a 90-degree triangle. You do believe you need to do Pythagorean theorem. Now I'm not going to, bore you with the a squared plus b squared. I'm going to go straight to the answer. Ideally, that's saying 8 squared minus 5 squared. Take the square root of all that jazz. Will get you this side. I hope you see that. Plugging it in right now. Shoo fire. I got root 39. Heaven help me. Well, that's this one. Guess what? These are congruent because of that perpendicular. So they want the whole length of the chord. So I'm going to go 2 times root 39. Golly, I'm telling you, it is too late for me to be doing this right now. Alright, I'm going to hit the times 2. I'm also going to hit the SD button just to get decimal. Kicks and grins. We get 12.49, I think, is an okay answer. Skadoosh. Remember, if I want exact, I want this top. Ooh. Again, if I want exact, I want this top number. If I want rounded about at least 2 decimal places, or the hundredths, I want that. So read the directions to find out. They didn't tell me, so I do what I want. I'm grown. Again, some fun facts. Tangent radius theorem. If a line is tangent to the circle, then the line that is perpendicular to the radius of the circle is drawn to a point of tangency. What this is telling you is the radius, diameter, whatevs will intersect the tangent at 90 degrees. This is how people find the center of a circle. Okay? They can use the T or some other perpendicular shape, bump it up against a circle, maybe even bump up another one. Okay, well, maybe if I can get it through the center, boom. Take that. You can find the center when you have two t's. Honestly, you only take two t's to figure it out. Okay, as long as they're the same t's. Mr. T. Two t's. Trees. Now we have trees. Two trees. Three trees. T's. Three t's. Alright, moving on. In fact, don't even draw these. Yeah, I'm hearing voices now. I gotta get out of here. These are a little tough, but you can handle it. Okay? In the diagram RS, we have the radius. We got ST being tangent, which means this makes a 90 degrees right there. And we are asking if is ST tangent. If it is, that means this has to be 90 degrees, which means the legs squared should equal the hypotenuse squared. Okay, so I'm just going to plug this in real quick so I can hurry up and get out of here because it's getting spooky. Spooky season's supposed to be over, but it ain't over in the school when you're all by yourself. Boom. Equals, it is tangent. Yes. Check RS's checkpoint. RS is the radius of R is ST tangent to R. Go ahead and pause the video and try these two out real quick. Alright, I'm back. Whew, guys, remember, you can swing that bad boy up and get 5 right here, which makes this whole hypotenuse 13. Same thing over here, swing the 12 down. 12 plus 7 is 19. So to check, 5 squared plus 12 squared should equal 13 squared. Again, use your calculator, but I think this is one of those special triangles. Indeed it is. 169 equals 169. Check. So yes, it's tangent. Try that again. Yes, it's tangent. Over here, 19 squared should equal 12 squared plus 16 squared. 19 squared, believe it or not, is 361. And 12 squared plus 16 squared is 400. Those are not equal. Not tangent. Sad. Not tangent. Cool. Should be able to find the value of x, but just looking at it, you should know. That's right, 3. Man, there's that beeping again. I'm telling you, I gotta get out of here. Again, this is a worksheet. I have the answer key, pretty stinking easy, solving for x in places, and vice versa. And guys, I know these look hard, but just think outside the box. You can figure it out. Okay? Just think about it. And I'll give you that later. Whew. Alright, today I will give you a triangle chicken. Draw a triangle, put the wings on it, legs, head, beak. I'm going to make them opening, eyeball, that thing under his neck, the thing on top of its head, yoke, yodel, I don't know what it's called. And he's saying, he's telling you a good thing. He's saying, math is always right. Chicken said so. Okay, I'm done here. Bye-bye.